Hello, everyone. Thank you for sticking around to the last lab of the day. My name is Krastin. I'm an education engineer with HashiCorp, and today we're going to talk about building a golden image pipeline with HCP Packer and HCP Terraform. Now, along with us here are our teaching assistants. These are Luca over there and Emil over there, as well as Moss online. And if you have any questions for us, they will be here to help you out. Pass the microphone on to you. And feel free to raise your hand and ask a question, even while I'm doing something and explaining something. If you would like to ask a question, you can get their attention, and they're going to signal to me. Now, what we will do here today, we are going to make your image building and provisioning workflows faster and simpler. How do you build a golden image pipeline? Well, with Packer and the Packer artifact registry, that's very convenient and very fast. Packer as a solution helps you build the images into the artifacts you can reuse. With the Packer artifact registry, you can use workflows related to security, auditing, and compliance to simplify and make this management of the artifacts easier. And of course, with Terraform, we can provide and we can provision this infrastructure, and we can deploy it in different target destinations across different clouds. Now, why are HCP Terraform and HCP Packer bedded together? Because of the systems integration between them. So with HCP Packer, you have all the workflows related to the artifacts, publishing, releasing, revoking artifacts, in case you have, let's say, a security issue or just end of life. And with Terraform Cloud, of course, you can fetch these images from the artifact registry, provision them, and also validate whether the artifact that you're provisioning into an instance is validated. This is a diagram of what we're going to do today. If you take a look on your left side, we're going to see we have 3 images. We're going to build one logging image that runs Grafana and Loki with Packer and put it into the HCP Packer artifacts registry. And then we're going to use Packer to build a golden image. That golden image, we have pre-configured logging towards the Loki artifacts instance. So furthermore, when we deploy our third and final image, the HashiCorp image, this is an application image that inherits the golden image. All the logging configuration that you configured for the golden image is going to be inherited automatically, and you're going to see how hopefully the image is going to log to our Grafana and Loki solution without any kind of configuration on our part. Furthermore, we're going to use a webhook functionality from HCP Packer. Now that is going to help us automate events surrounding the lifecycle of the HCP Packer artifacts registry. So every time you make a new image, or you release a new one, or you revoke one, this is going to generate an event, and you can use that webhook to make further automation within your systems in your environment to let your stakeholders know that whatever image operation has happened, for example, you've revoked an image, has impacted them or will impact them soon. Usually, this kind of automation will use some sort of messaging system or an email or kick off another CDCI project. In this case, as an example, we have tied the webhook towards a Lambda function that will run in AWS. It's going to take the data related to the event and we'll dump it into an S3 bucket. And we'll see the data as a JSON file in the S3 bucket. Finally, of course, we're going to take Terraform and we're going to use the artifact repository to make sure that we're deploying the right image. We're going to get that from the AMI repository and we'll deploy it into EC2 instances. Now, how does HCP Packer help you in your managing of artifacts and images? In these screenshots here, you can see that the relationships between the parent and the child image is clearly listed. If you have a parent image that is out of date or revoked, you will see the impact on the other images that use that as a base golden image, clearly listed in the HCP Packer. That will help you manage your systems and your images. And one more thing that you can use with HCP Packer is channels. Now, channels are tiny little groups per artifact that you can use to separate different versions. Most clear example for that is to have a channel for production, channel for testing, channel for QA. But of course, you can also use these channels in any other different means that you may see fit. We're going to do that in the demo, and you're going to see how channels work. And finally, we're also going to run some image compliant checks. These are so-called run tasks at the end of HCP Terraform runs. In this demo here, we're going to use such a check to make sure that the AMI that we're using to deploy an EC2 instance is not revoked and is still correctly up to date. And also, we're going to make sure that if it is not the case, it's not going to let us continue with our Terraform deployment. Now, this is the tutorial that we will be loosely following along. You can also check it out later at your own pace. That's a QR code that you can snap now. And if you get any kind of questions, again, along or after the presentation, feel free to ask. Now, we're going to jump right into the demonstration. I have prepared a nice little runbook for you, because there's a lot of commands, and it's could be a lengthy presentation based on how long building the images with Packer takes. This is a little unpredictable. We're going to build them live. So we could be also a little bit either out of time, or we could finish a little early. So there's a certain unpredictability there, but never mind that. So first of all, we're going to start by setting up our HCP. I have a link here, which when I open, I will wait for it to load, OK. Right, so first of all, we're going to start off with the organizations. And we need to have a project. I can make a project here, but I have already created one for you as so. I've done that so that I can preset some credentials for you, but we're going to go over how to do that too. So once you have a project created like this, we're going to jump back, and we're going to take that project ID and export it in our terminal. So the way that you find your project ID is up here in the URL, right after project. You can see, if I can select it, yes. That's your project ID. I have mine pre-filled here for you. So this is going to instruct our, oops, wrong one. Our Terraform CLI to run against the correct, sorry, yeah, our Terraform CLI to run against the correct HCP project. Next, we're going to create a credential within HCP for Terraform to use and to manipulate HCP with. We're going to go here, and we're going to go to service principals. Now, this is my pre-configured one, but when you are creating yours later, you can name it anything you want. It's important to have the scope set to project and the role set to contributor, so that it can actually edit. Once the service principal is created, we're going to go to keys. And here we'll generate a new key. Now this is the insecure part of that. You need to copy that and keep it safe for a little bit later, because we're going to use these to configure HCP Terraform and your own terminal too. I will just delete this one now, and we will move along. Next thing, we're going to set up our shell, the credentials that we just generated. We're going to paste them here and run these two commands. I have copied mine in this little file, and I will source it so that my secret remains a secret. Finally, we're going to create an HCP Packer registry. I'm going to go back here, select our project, and go to Packer. I will click Create a Free Registry, and there we go. There is nothing in it yet, but that's going to change very soon. The next thing we're going to configure is HCP Terraform. Now, first thing that we need to set up there are the credentials. Ideally, if you followed the preparation document for that, you already did that. But if not, it's very straightforward. You create a new variable set. The name specifically, in this case, doesn't matter because we're going to attach it to our project here. And you set up your AWS account secrets here, along with your HCP secrets here. The client ID, the client secret, and your project ID, almost identical to your CLI setup. Now, once that is done, you need to apply that variable set to your project in Terraform Cloud. After that is done, the last step is to specify which organization you're using in Terraform Cloud, and I have named mine accordingly. It's called Krastin's organization. Now we are ready to deploy some infrastructure. Following the tutorial, you're going to get to clone the repository. I have already done that for you. And the first thing we're going to create here is an SSH key that Packer will use to install into the actual golden images, log on, and then provision them. First of all, we're going to go into the Webhook directory, and we're going to do a Terraform run. While the run is deploying, we're going to take a look at what exactly is it that we're deploying. The webhook is our part of the automation that's going to log all the events related to HCP Packer registry, and it's going to send them over to our S3 bucket in AWS. Now, the config for this is also straightforward. You have a resource, Terraform resource, and HCP notification webhook. And we have a little workaround here for 10-second wait, so that we're sure that the API gateway that we're also deploying is ready to accept connections. We have the configuration URL that this webhook points to. I'm going to see that resource a little bit further down this file. And probably the most important part here is the subscriptions. We see that we have subscription to events, and we are logging every single action in the events coming from Packer. The rest is a part of our logging so-called solution to log the events. We have an AWS Lambda function that is created. It takes all the events from that webhook. My deployment is ready. That's great. And you can see that it is running a function. It's a very small Python function that takes the event and dumps it as a JSON in an S3 bucket. So here in this file, well, in this function, is where you would put your own automation. That could be Slack messaging or emails or any other kind of response scenario to an event in HCP Packer. So we have our webhook deployed. Next thing we're going to do is we're going to build our logging image. And that's going to take a while, so I will execute this. And I will go over the Packer config file. Now, we are building the Loki image here. This is going to show our interaction and our automation of how you can automate configuration in your golden images. This is a very simple Grafana and Loki instance. We're going to take a look at the provisioning files in a moment. This golden image will be next deployed into our infrastructure and will be made ready to accept all the logging coming from our application images that we will make later on. You can see it's a straightforward Docker running Grafana. We have a Loki setup script that sets up the environment, the user. We have a Loki configuration for data retention and logging. And we also have the actual script that gets Loki there. That's all this provisioning does. Now, Packer is going to take a little longer finishing that artifact build. So now it's a good time to take a look at our S3 bucket and the webhook we created and see if there's any activity in it. I think, oh, I do not have the tab ready. I will go back here. Yes, I have a link here. This is a little small, is it? Yeah, that's bad. So my S3 buckets are listed here. This is the bucket we created earlier. And we have 2 events fired here. We can take a look at the second one because I already know that the first one is just the webhook registration. It logs when it first starts. So we're going to download this JSON file, and I will hop onto another terminal right here. I'll make it a little bigger for you guys to see. And let's see what was logged from our webhook. You see the resource names, the project, the registry. You see the action that was tied to the HCP Packer artifact registry. It was create. So this thing created a new HCP Packer. This is the build that is running here, our Loki image. You can see there's more data surrounding this creation. There's a bucket ID, there's the name of the actual artifact being built, and where exactly is it being built from. The AMI is almost ready. So what we can do next is take a look at the channels in the HCP UI. And before we do that, I'm going to clean up this file here because we're going to check out more of these JSON files later. I will hop over to HCP. I will open up the Packer tab. And here you see that now in the artifacts list, we have the Loki image that we're going to use in a moment to deploy an instance of. And we can explore that. And we can see that there's no builds yet because the build is currently ongoing. And if I click on versions, you're going to see that there's a build still running here. Once Packer finishes this build, there's going to be a version 1 here. And if you click on it, there will be a bit more data about your artifact in here. Back to the artifact page, here we also have the channels tab. So the channels tab is, as we said earlier, you can group versions in specific groups based on whatever use case you might have. By default, you get a latest channel based on what was the last image you pushed towards Packer. And if my version has finished building, maybe I can make another one. But this one is taking a little too long. Yeah. Okay, if we can pause for a second if there's any questions. I see somebody there.
Hi, thank you for a great demo. Is it possible to instrument the build of, let's say, container images or Docker images through this workflow? And so let me finish.
Yeah, oh, sure, sorry.
Just forget. To deploy the Docker image or container image, for instance, into ECS, like, end-to-end workflow.
Yeah, from my understanding and experience with Packer, it's about building images for AMI similar registries for multi-cloud solutions. I'm not sure if there is an Docker registry plugin for Packer. Is there? Maybe Luca, would you mind elaborating on that?
Yes, as far as I know, there is a, let me say, a kind of plugin that you can use with Packer in order to build also container images. So you can use this pretty much the same workflow in order to manage all your environments.
I'm not sure if we have a tutorial for that. Maybe that's a good idea to expand on further. Thank you for the question. That's a great point. OK, let's move on, because we have a few more builds to do. If you have more questions, you can ask them while the builds are running. All right, we have our artifact image for the Loki logging solution. Next thing we're going to do is we are going to deploy it. I'm going to go to infrastructure, do a Terraform init, and we're going to do a Terraform run. Now let's take a look at what are we deploying. We have in here some provider data sources and plugin, and this is where the interesting things come up. We have a data source from HCP Packer about our Loki image. Which bucket as artifact are we using in which channel? Oh, OK. I forgot to do something, and that's a very good example. So we're getting an error. The error is there's no production channel, because my variables, I have set the HCP Packer channel as production, but I did not create it yet. So let's do that right now. We're going to go to the image that we're going to build, new channel. I will put production here. I'll pick version 1. And I'm not going to restrict that channel specifically. So now that I have the channel production with version 1, my Terraform should be slightly more successful. Back onto the code. You can see that Terraform queried the data source for this bucket name and this channel name, and didn't find the image at first, and now it will do it. The next thing is the data for the artifact. You can pick which platform you're deploying that on, and which region you're also doing that. And of course, finally, we have the AWS instance of Loki that uses the AMI from this data. And this time our plan was successful. That's great. Now we have one image built and one channel created. We can take a look at our JSON logs again and see if there's any difference there, and there should be. If I refresh these, we have a few of them. You can see I will pick the latest one because I suspect that that one was the one related to me creating the channel. So let's take a look at that one. There we go, that's a different one actually. And you can see event action assign. So I just assigned, I created a channel and then I assigned version 1 to the channel production. This is the log for the second action for assigning the version to the channel. You can see who did it. You can see the artifact name, and you can see also more information related to the channel. You can use that to automate notification based on however you see fit. Now, I think our deployment should be ready by now. Perfect. So what have we done so far? We have created an artifact image for Loki and Grafana, and we have created a channel in HCP Packer. We have assigned a version to it, and we have deployed an instance from that channel. OK, but this is just the preparation for the actual deployment. So now our Loki instance is running. What we're going to focus on next is, I'm just going to save these for later. They will come in handy. And you will see why in a moment. What we're going to do next is we're going to integrate HCP Packer with HCP Terraform. Now, the way we do that is we go back to Packer, to the buckets, and here you get an endpoint and a token that you can use to integrate HCP Terraform with Packer. So let's do that right now. what we need to do is switch back to HCP Terraform and set up these credentials there. And we will set these credentials for a specific run task that will check whether the AMIs we are using are approved in HCP Packer. So I'm going to go to settings. There we go. Now I'm going to go to run tasks. I will create one run task, which I will call HCP Packer. Now here, I'm going to grab the endpoint and the token from HCP Packer. I will put them into HCP Terraform. I will create that. And this is our run task. Now, we are going to assign that run task specifically to the workplace settings as a mandatory work task that will run after every single plan. So we're going to go back to workspaces. There's 2 workspaces already created for us from our infrastructure deployments, the Webhook and our Packer golden image. I'm going to go to settings. I'm going to go to, oh, the wrong one. I'm going to go to here. This is the settings of this workspace. And for run tasks, for post plan, I will pick this run task. I will set it as mandatory. So if that run task fails, our deployment will not run through. All right, now next, we're going to take the information from the instance that we deployed as a logging, its IP address, and we're going to configure our golden image artifact to always output the logging to that destination. So I will use these 2 set commands, and I'll kick off the deployment, and then we will review again what exactly are we deploying. So let's go to the golden image folder, and let's kick off a Packer build. Okay, with Packer building the image, we can take some time at a leisurely pace to look at exactly what kind of golden image we're building. GitHub is very easy, Git is very easily marking this as modified to show me what changed. And you can see here that in this Docker daemon config, I have a Loki logging with the IP of the Loki instance that I just provisioned. And in Prometheus config for Prontero, I have the same IP setup as destination. These 2 configuration files are going to get built upon and into the actual golden image that we'll use later to deploy an application image with. The configuration file for Packer for building this golden image is familiar and similar to the one used for the Loki image. We have the plugins, we have some naming conventions with the timestamp, we have the base AMI from Amazon, and the EBS base instance that we're going to build upon. There is one for east, one for west. For an example, we're going to only deploy the west one for now, just to speed the process up. And then the build path, we're going to see that there's a provisioner for the SSH key that we created a little earlier, and we have a couple of shell scripts that Packer is running to set up, in this case, Docker, to set up Prometheus Trail, to run it, and to change some auditing rules into the actual, I think it's for Docker. So Packer is currently building our golden image, and will later register it as an artifact in the HCP Packer registry. Now, while this image is building, we're going to configure Grafana and its data source. I will open up the URL. I will log in, and with the default credentials, I will skip that for now. This is rather tiny, isn't it? Let me make it a little bigger. Yeah, that's better. So we're going to quickly set up Loki as a data source here. And the address for Loki is one from the Terraform output from earlier. Okay. Now, once we start deploying application images using the golden image, ideally and hopefully, the logging of these images is going to show up here without any further configuration based on that specific issue. Let's jump back here. Okay, Packer is still running. So just a quick recap. What did we do now? We configured the Loki instance to use a Loki data source in the Grafana platform. And we are currently building a golden image with Packer that has pre-configured logging pointing to the address of our Loki instance. Now, of course, ideally, if you do that in production, your destination is hopefully going to be a domain name here. Probably good to point out. Okay, Packer is still taking a little longer to wait for AWS. While this is running, we can take a look at our events here again. 6. So if I download this one now, and let me see if I cleaned up. I did not. Let's download this JSON and take a look on the logging. This is most likely tied down to the golden image that I'm building right now. And yes, it is. This is an HCP Packer create action. We are creating this artifact. And we're using this organization project. Okay. Back to Packer. The next step here would be to create a channel for the golden image, just like we did for the Loki image, and set a version for it. We're not ready yet because the image is still wrapping up. So if you have more questions, now is an absolute perfect time. All right. Okay, while this is running, we can take, we're almost there. While this is running, we can take a quick look again at the HCP UI, now that we have more than one artifact in there. This is an interesting point to make. You can see that the golden base image has the relationships between the parent and children artifacts as undetermined. That's because it's still building. And you can also see that the Loki image has the latest version of V1, the one that we built a little earlier. Again, if we click here, we're going to see standard channels. And there we go. Perfect. The build is finished. Okay, so we just finished building our golden image. Now, what we're going to do next is we're going to create, again, a channel for it. We'll call it production. And this is case sensitive. So we need to pay attention to that. After the channel is ready, we can finally build our app image that inherits the golden image. So I have a HashiCorp image here that I'm going to kick off the build for, and we'll inspect the configuration for that right away. Now, HashiCorp is a demo application that we use for demonstrations like these ones. It's basically a web shop for coffee. If we take a look at the configuration file for Packer, you can see, again, very familiar structure. You can see the data bucket name is the golden image. So this is going to be used as a base image for this build. And again, the channel name is production, the one that we just created. There's also an HCP Packer artifact data source here, saying where exactly this is going to be built. We have two, one for east, one for west. And of course, the instance type, the deployment type. And last but not least, of course, the provisioning. So what do we have provisioned in this application image here? Well, first of all, we have all the provisions we did for the golden image, which includes logging towards the Loki instance address. Here, we also have clearly the SSH key. We have a configuration file for HashiCorp, which points where its database is. And we also have a Docker Compose configuration that we use to launch Docker Up. What do we have in there? Very straightforward. We have two images who's going to run into containers. We have the product API and the database for the product API. So once this build finishes, we'll be able to deploy that image. And again, here we can see this is the HashiCorp's image. Once that build finishes, that image will be tied down to the golden image. You're going to see the relationship listed here. And as you're all familiar with already, we're going to have to create a channel, but only when the build finishes. Now, before we look into the JSON events log again, any questions so far? We have a question here.
Simple question. Can you schedule builds?
I'm sorry?
Can you schedule builds of AMIs?
You mean the Packer runnings? Yeah, this is up to you. You can schedule them based on something very elaborate. You know, you can have a...
From past experience, like I found it beneficial to schedule a lot of the builds, because what happens is if you don't build something in a few months, you might find, particularly if you have to call out to external resources, that they no longer work. So at least if you're building regularly, you'll very quickly find if there's a fault with the AMI creation. You know, URLs change, something might happen to that endpoint and you can't pull what you need to pull, and you might not be able to pick it in. Yeah.
I understand your question. You're asking for what does HashiCorp recommend in terms of scheduling builds. I'm not sure that I can answer that question right now. Does anyone of our TA have a strong opinion on that? I think Luca, yeah. Thank you.
I mean, the answer is pretty much always the same. It depends on your workflow. It depends if you want to trigger this kind of build by a commit or a pipeline managed by something else. If you want to trigger a pipeline by a request internally. I mean, if the question is how is going to be the frequency on the build, or if you want to be sure that, for example, every day you have a new build image. I mean, it's a complex question. I mean, it's not very easy to answer with a pretty much.
I asked the. Oops, sorry, it's really loud for me. I asked the question because you might also have to do patching of your AMIs. So not just to test things that haven't broken, but you might have to patch to obviously pull in the new dependencies for the operating system.
Yeah, I understand your question. It's a fantastic question. I think the answer, as Luca said, is different for everyone because you can put a lot of work into that, depending on how much you want to get out. That's the difficult line to thread, right? how much are you willing to invest for how much. If you have more questions about that, we can also, or if you'd like to share your experience, I'm very curious to hear that. Come find me after the session. That would be fantastic to chat about. And thank you for the question. Our build has finished. To me, it was almost instantaneous. All right. We will now deploy our application image, but first, what do? So that our Terraform run doesn't fail, we create a channel. I will create a production channel again. And there we go. Now, here the build gets a little bit more interesting because once we start to deploy this instance, the run task for the validity of the AMI is going to execute. So we're going to see some cool output in Terraform. What did I do here? I uncommented in my infrastructure folder a little data source for Packer, and I'm going to deploy an instance using the very same data source. I'm going to copy this. And now this Terraform run is going to invoke the post run task. And because the AMI that we're building is sourced directly from HCP Packer, because also there's only one artifact there, this check should succeed. And once the refresh is done, you'll see at the end of the planning part, just a little longer. Okay, there we go. It's executing the post-plan tasks. And we see that our check has passed. Now this is going to deploy an instance of HashiCorp to EC2. It should be faster than the image building. And once that is done, we're going to make sure that this instance is working. We're going to make sure that it's outputting logs to the solution. And we're going to see how and what is the relationship in the HCP Packer artifact registry between the golden image and this application image that inherits it. And we can start with the second one already. We'll open HCP Packer. And if I look at all the buckets, there you go. The relationship between the golden base image and the HashiCorp image is outlined. Both are up to date. And if I revoke or I update the golden image without deploying the HashiCorp image, I'm going to get a warning right there. Now, again, this is just the HCP Packer registry. This has nothing to do with the instances that we're deploying, at least so far. If you want to update your golden image and you want to make the dependency correct, you need to rebuild, of course, the child image that's using of the golden image. So let me take a look. I think this deployment should be done by now. Yeah. Oh, and see, I forgot one last thing. The output for the endpoint of the apps. So that should be a quick change. And while this is running, we can take a look again at our events. However, we will not look at the JSONs now. We're going to look at another part where we can see the events, and that is, oh, my bad. We'll go back to HCP, and I go to my project. Now, the quickest way that I found to find the webhook is through the active resources right here. So this is our webhook. You can see all the events that this webhook has subscribed to. Just for Packer here, it's about all the version manipulations and all the channel actions. And if you go down here, you'll see these are all the times our webhook has fired and sent a post to the Amazon API gateway. You can inspect these webhooks from here too. You can see the requests. Look familiar? It's the JSON files. And of course, the response from the API gateway side. Let's go back to Packer. My Terraform run should be ready. OK, there we go. So now I'm going to make sure that my application is running. There we go. It's an API response for all the available coffees there, and we can make it even a little bit prettier. Yeah. If my application is running, it means that my application is logging as well. So we're going to go back here. And if I click on Label Browser, there we go. If I click on container name, we'll see that we have 2 containers logging here. These are my API and my database. See that they haven't logged much yet. Show logs. Oh, there we go. And if I sort them by unique labels, you can see that we have the API logging in there. And hopefully also the DB. Yes, the DB here. They're both alive. So we achieved logging without configuring it on the application images. Now, what we're going to do next is we're going to test the post-run tasks for the webhooks. What we're going to do is we're going to build, oh, actually I should kick that off while explaining. I'm going to build another version of my HashiCorp's image. I'm going to bump these versions up by 1. And I'm going to kick off another build. Yes. Now, what this will do is here. There we go. It's already logged as creating. We will have 2 versions here, one with the older version of HashiCorp, one with the newer. We're going to force the Terraform plan into a state where the post task checks for an AMI, and we're going to make sure that Terraform wants to deploy the AMI that we're going to revoke here. We're doing that to showcase what will happen if somebody tries to deploy an AMI that you have revoked from a channel. Before we do that, however, we need to do a slight change in Packer. And in order to use the version reporting in HCP Packer, you need to enable Packer Plus. Now, if you do that with your account, you should have some free credits there once you sign up. And once we do that, you can see immediately that we get some extra functionality that we're not going to explore right now. But once our build finishes, here, we'll be able to go back to our infrastructure tab and try and plan a deployment of another version of the app image. That deployment is going to try to get the AMI that we're building right here as the source. And we will revoke that AMI and see what happens then. Again, a little downtime, waiting for the image build to finish. Perhaps some more questions if you have any. There's a question here.
Hi. So my question is like, when we are building these images, right? how can we scan those images and if you want to show the results? So in terms of what are the possibilities so that we can inspect those images, show the results to CTC so that we get the approval.
When you say scan, what exactly do you mean? Security vulnerabilities or?
Kind of.
Uh-huh. This is up to your SecOps. You can scan the source files for the build, or you can just build in testing and scan there. I'm assuming you're asking about security vulnerabilities in terms of, let's say, exploitable software. Or do you mean leaked credentials?
It's about everything, I would say, because the whole point is that once we have any image, right, we need to show the results so that we get the approval from CTC. And security is very serious about it. Unless they are not seeing, they are not going to approve. So I was looking for the possibilities if we can plug in something or if there is any inbuilt functionality which can be used. So once we are building the image, we can generate the result as well for scanning and publish that.
Right. The way I would implement it, and I'm not a solutions architect, but the way I think you could do it is, of course, first scan the source for the Packer build. What is it getting? Where is your provisioning coming? Like, what are the files there, so that you can avoid the cost of building an actual image and then scanning it. But of course, building it and scanning it is probably also necessary. Again, depends on your security situation.
Yep, that's fine. Thank you.
We have one more question.
We also have a similar security requirement. So we have to scan our instances, and we have to understand the whole supply chain of what's on that instance. So could you not pre-install the security scanner, whatever it might be in your organization, and as part of your Packer script have a step that's, hey, you're done building, scan me, and then if it comes back critical, you could fail the build?
I think you can leverage specifically with HCP Terraform, you can leverage the post-deploy run tasks to do that for you. I don't know, it's feasible based on...
So when you say post-deploy, is what does that mean? Is that after the image has been created?
So the image is created by Packer. While Packer is creating it, it's just a snapshot in this case in AWS. I'm not aware of any functionality that helps you test that image while it's still a template.
Sorry, but you're running scripts to build that image. So why can't you scan as part of your script, and then if it throws an exit code of 0, then it's just not going to build because it's a build failure. And that way, if you have a security vulnerability and it's major, it's not going to build anyway. So that way you can have whatever your security tooling is tell you that there's a vulnerability, but it does it at build time rather than needing post hoc or something.
That would be a really good solution. Yeah, you can avoid deploying that image. Our TAs, do you guys know if there's any kind of... Yeah,
From my point of view, you can leverage the run task feature in order to enable a run task on a post plan rather than a post apply, and integrate Terraform Cloud with a third-party solution like something like Snyk or Prisma Cloud in order to figure out if there are some security issue in your image before deploying in an environment. Or you can add other security scanning tools managed by a pipeline before building a Packer, before executing the Packer build. So there are a lot of, from my point of view, a lot of tools or actions that you can apply in order to remediate or in order to scan your image before creating it. Does make sense?
I think the one point that's left unclear is if the provisioner fails, does that fail your Packer build? So you can configure that. You can skip over it or not. And what you're pointing out is probably what you want. You want the provisioner to fail. Yeah, you could probably do it this way. That's a cool proof of concept to test. OK, we have our image built. Let's move on. And if you have questions, we'll check them out in a moment. Now, I'm going to use this image here. There we go, version 2. And I will assign it to my production channel, like so. Now, if I run Terraform plan or apply, it's going to try to use image version 2 if I'm deploying the HashiCorp stat image. Now, what I'm going to do next is revoke image version 2. And I will revoke it at a future date. Now, why am I doing that instead of revoking immediately? I will revoke to a future date without having a predecessor to fall back towards. So I'm going to force the channel into a state where the last image for that channel is revoked. Now, if you revoke it right now, HCP Packer automatically says, oh, you revoked it, OK, we go back to version 1. And then none of your deployments will fail. But we want to make that deployment fail. So I'm going to revoke that like this, because future revoking I can pick to not roll back the channel. And I will schedule it for 1 moment ahead. So I forget, do I need to put 15 here? OK, and if I click here, it will tell me for... Oh, that seems about right. So in a few moments, this should hopefully revoke. And then we're going to run a Terraform plan. Let's take a look again. There we go. Now, if I go to channels, and you will see that the latest channel has rolled back to version 1, but the production channel has stayed to v2 because we told it not to roll back. Now, if I try to make a plan now, what's going to happen? Terraform is going to query the Packer registry. What's the last version in the production channel? And that will be version 2. However, version 2 I just revoked. So the plan will go through. The drift will be the change in AMI for the AWS instance. But hopefully, the post-run task is going to check and see that that AMI has been revoked. And that means that the post-run task will fail. And once the refresh happens, there we go. If we try to run an apply, it will not let us do that because we set that task as mandatory. And this is how you can leverage version policing with HCP Packer in HCP Terraform. Any questions? There's a question over there.
Hello. OK. In what scenario would you not want to roll back if your version has been revoked? Surely, if you're in a production environment, in, say, a self-healing scenario, you'd knackered. You'd want it to roll back, surely, because in your production environment, it would be, in theory, a stable version. Mm-hmm. So what scenarios would you have where you wouldn't want it to roll back to an earlier? That camera is so distracting. But yeah, that's the question.
Thank you for your question. Yes, in a production environment, I also do not see a reason where you would halt the pipeline. This is just to showcase that the check works. That's why we had to go around with the future deployment with no rollback. If you're doing testing of sorts, which is not in production, then maybe you would like to trigger a cascade fail. Maybe that makes sense. If an instance or building fail is part of something that you think your system should be able to survive, if you don't treat your production as much of a production in a way. But yeah, in production environments, I would try not to get to this state either. Any other questions? All right. Then, there is a question. Yes.
Yeah, just one more question. So, for example, I have configured an image in auto scaling, right? My services are running properly fine. And we have revoked the image. It means if any more instance need to be created or something, it will not be able to find that version. So is there any dependency when we are going to revoke any image? Is there any way to find out this image is used in so many places and that need to be fixed before revoking?
I see. There is no. So, as far as I'm aware, and our TAs here can interject if I'm wrong, if you're using HCP Terraform and you're using constant state checking, once you revoke the AMI, the state should drift, and Terraform should detect that. So then it just kick off redeploying your images.
I can understand like drift detection, but it's still like, because we are running enterprise, Terraform enterprise, right? And whatever version you are talking about, we are still behind that. So drift detection and those things are still need to come into the picture. And whatever you are explaining here, like run task, right? Even run task, we can't achieve all the things. You know, as I mentioned, right? CTC is saying we want Wiz. Other team is saying I want Sneak, right? So many run tasks are needed to complete something. The whole point is that how many run tasks we are going to do, right? So we can't say answer of all the questions is run task. That's not the right thing, I believe. And that's the reason I'm asking if there is any easy way to identify this thing before revoking, right? We might keep revoking, and later on in the midnight we are getting called what you guys have done right.
Yeah, I don't think I can answer that question in terms of not using HCP Terraform. It will be not a simple solution, I assume. If Luca has some thoughts on the subject, yeah. Yeah?
I mean, I don't have a very direct and clear recipe in order to solve this issue. Of course, revoking an image, it's a very strong decision. So it's more like, for me, a workflow and a process thing rather than a technology stuff. So if you want to revoke an image in production, of course, you need to define how you want to mitigate the process, how you want to keep it works. So yeah, I agree with you. In case an auto-scaling group, of course, if you revoke an image and the auto-scaling group need to scale horizontally, you're going to face some issue, okay? So yeah, probably, for example, a Git flow approach in order to merge the feature, for example, for a severity issue in your image, maybe should help you, because before merging the new image in your main branch that is linked to the production environment, you can test in the staging environment, and then you can figure out what is going to be the impact about revoking the image for you in the production environment.
And is there any states are generated like kind of how many places or something, or for example, this particular image is used in these many directories or these many Terraform files, some report kind of, because the whole point is that we are not talking about a small team. We are talking about thousands of teams who are working. There are so many different users who are deploying things, right? So might be one team is developing something, another team is testing something, another team is deploying something, right? So these kind of scenarios, we need to have something. If we have states, for example, it says this particular image is getting used in 500 places. We might first need to fix those things before revoking or those, right?
I understand your question. The part of HCP Packer here is a little decoupled from the functionality that you're asking about. This is just for artifact management. And yeah, that's a significant challenge that you're facing there. Luca, is there maybe?
There is another question.
Oh, sure.
I mean, if the topic is pretty much close, I don't know if there is.
Yeah, there's no simple and easy answer to that. If you'd like, step up to me after the presentation, we can discuss at length. I'll be very happy to. Yeah, let's go to the next question.
Thank you. Mine actually is a follow-up question on revocation in production. So one of the scenarios where I can imagine it makes sense if, for example, I'm implementing something, deployment strategies like Canary or AB, and I want it to fail because I don't want new Canary or to be successful. So do you have any good advice or strong opinions how I can implement those strategies for production like Canary or AB here or using this tool set?
I think for Canary, you can just use different channels and split your image building in different channels and then deploy these channels with another solution that maybe Luca, can we do?
Right. Just
sure.
This for channels and then something like a load balancer in front to use those channels, to expose those channels to production system.
I think so, yeah, because when you do canaries, you have different versions. You need to know basically which version is where, and maybe the different versions have different development to them. Maybe one release is faster.
Okay, so does it mean that channels, in fact, it's up to me to group channels?
Correct.
Okay.
Absolutely.
That's helpful.
Yeah. You can group them based on, deployment environment like we did here. You can also group them based on, let's say, blue, green, or whatever.
Thank you.
Yeah.
Thank you.
All right. Perfect. Well, in that case, thank you for attending this lab. I hope you had fun, and thank you for following along. And I'll give you 5 minutes back for the happy hour.